From coast to coast and worldwide on the Internet, this is Coast to Coast AM with Art Bell.
Oh, what a treat you're in for. Here comes Dr. Michio Kaku. He is an internationally recognized authority in theoretical physics and the environment. He holds the Henry Summit Professorship in Theoretical Physics at the City College, and that's of New York, and the Graduate Center in the City University of New York. He has lectured around the world, and his PhD-level textbooks are required reading at many of the top physics laboratories in the world. Dr. Kaku graduated from Harvard in 1968, summa cum laude, and number one in his physics class. Number one. I remember those kids. He received his PhD from the University of California at Berkeley Radiation Laboratory in 1972, and then shortly thereafter actually turned down the opportunity to go to work making bigger, better bombs. Held a lectureship at Princeton University in 1973, joined the faculty at the City University of New York, where he has been a professor of theoretical physics for 25 years. His goal is to help complete Einstein's dream of a theory of everything, a single equation, perhaps no longer than 1 inch, which will unify all the fundamental forces in the universe. Dr. Kaku coming right up. Ladies and gentlemen, Dr. Michio Kaku. Dr. Kaku, welcome back to the program.
Art, glad to be on again.
It's always so good to hear your voice. It really is. I am going to be in your fair city next week.
Oh, is that right? New York City?
Yes, sir. New York City.
The Big Apple.
The Big Apple. Recluse Me is going to break away and go all the way to New York City for the premiere of The Day After Tomorrow, that movie.
And congratulations. Well, it's not every time that somebody has a big Hollywood blockbuster.
Not every day.
Based on a book they wrote.
Yeah, not every day, huh? Mm-hmm. Well, based in part on the book we wrote anyway, and, of course, Roland Emmerich has added his magic touch to it, and it sure has. Holy mackerel, I have a pile of stories here. Some scientists in Britain are saying, ha-ha, yes, here it comes. Others are saying, rubbish. And it's a big, giant controversy, and I keep trying to say it's a science fiction movie, but administrations are worried. NASA, oh gosh, NASA, first they came out night, I was on the air, and NASA said, our scientists will not comment on this movie. They will not say a word. And then by the time I'd finished first hour, all of a sudden there was a reversal from NASA, and they said their scientists, well, okay, they can comment on it. So what a mess. It's a movie.
I think scientists are like ducking for cover, especially NASA scientists and government scientists.
You think so?
But I think your movie's going to be a real seat of your pants movie that's going to open a lot of people's eyes. Yes.
Well, if one looks at the archaeological evidence, and there is some which many scientists choose to ignore, there have been rather fast climate shifts apparently in our past.
That's right, 8,000 years ago and 12,000 years ago. And, many ice ages have taken place because when you tinker with Mother Nature and you tinker with the Gulf Stream, you tinker with the collapse of the atmosphere itself.
Yes. Are you aware of the measurements taken by Woods Hole and others? Very reputable scientific organizations that say the Gulf Stream is beginning to slow.
Yeah, there's, as the North Pole melts, fresh water begins to pour into the North Atlantic, and that's what we're worried about. The salinity of the North Atlantic is changing now, and that could be the tipping point, the butterfly effect. That could tip it over. And like we physicists say, even a butterfly at a certain tipping point can create a thunderstorm. The injection of large quantities of fresh water from the melting North Pole could be a tipping point for the North Atlantic Gulf Stream, in which case, hold on to your pants.
Oh, I know. Europe, indeed, could freeze. Western Europe could freeze. It would be a disaster, and I think that's why there's such a mess, Doctor, over this movie, because to me the best science fiction has always been that based in possible or even probable reality.
That's right.
And then you scare the hell out of people about that. I mean, that's good science fiction to me, my kind of science fiction. I don't like the fantasy science fiction. I like something that's based on, well, like Contact, for example. I thought it was superb. There's a lot of movies I really love, but most of them are based on at least possible reality, and maybe we got a little close with this.
That's right. There's a difference between Lord of the Rings and Jurassic Park.
Indeed.
Lord of the Rings is just pure fantasy. No one thinks there's a kernel of truth in Lord of the Rings.
Right.
But Jurassic Park, I mean, there's a kernel of truth there, you know. So it's something that you really have to think twice about when you see the movie Jurassic Park. And I think in situations like this, it's another situation where you really have to think twice. You know, is there a tipping point for the North Atlantic Gulf Stream? You know, and we have one big science experiment, the planet Earth, basically, we're tinkering with.
All right. Let's move away from that. Enough plugging into the movie, even though it is fascinating and the debate's fascinating going on over it. I've got a question. Somebody asked me a few weeks ago a question that I haven't been able to yet answer. What is the speed of gravity?
The speed of gravity, we think, is the speed of light.
We think, or we know?
Well, that's one of the reasons why NASA sent a $700 million gravity probe B into outer space just last month. It's one of the most expensive space probes that NASA has ever sent, a robotic space probe into outer space. And it will try to test once and for all Einstein's theory of general relativity, the foundation of modern cosmology, the foundation of black hole research. We want to nail it to the wall. And this is big business now, you know, trying to confirm Einstein's theory.
Okay, well, little old talk show me thought about it when the caller asked, and I thought, well, maybe you can't measure it because gravity is related to mass, correct?
That's correct.
Okay, and if the mass is already in existence, short of being able to create sudden mass, I'm not sure how you would measure it. How do they plan to do it?
Well, if you were to wiggle the mass, vibrate the mass, you would create waves of gravity emanating in all directions. And these waves, like a fabric, travel at a very definite velocity, and that velocity, we think, is the speed of light. Because space is not empty. We think space is like a fabric that can flap and bend and stretch. And we think that waves can move along this fabric. Like if the sun were to disappear, right now, it would take you 8 minutes to realize that, my God, the sun just disappeared.
Right.
And then 8 minutes later, the gravitational pull of the sun would disappear, and we'd be flung into outer space. Now, of course, we've never done that experiment, but we do believe that if the sun were to disappear, it would take 8 minutes for the Earth to fly into outer space.
Disappointing. We wouldn't have any warning at all. Well, maybe we would. We've got that satellite out 1 million miles, right?
Well, we have the Gravity Probe B out there, and it's supposed to measure what is called the missing inch.
No, I meant there's at about 1 million miles, I believe we've got a satellite that observes the sun.
Oh, yeah, that's right. There are satellites that observe the sun.
Oh, but wait. No, the signal coming from that satellite would be coming at roughly the same speed, so we wouldn't get any notice at all.
That's right.
Darn.
Light and gravity, both, would take 8 minutes to arrive at the satellite. And so we would have basically no notice at all.
Not even enough time to go, oh, damn.
Nope.
Or something.
Not even enough time for that.
All right, we're going to talk a fair amount tonight, I guess, about Einstein. Your book is about Einstein.
That's right, Einstein's Cosmos.
And what inspired you? Why did you want to write about Einstein?
Well, you know, next year is the 100th anniversary of relativity and E equals mc squared. And there's going to be a lot of hoopla next year. Next year it's called the World Year of Physics, as we celebrate 100 years of relativity. And this means conferences, this means TV specials. I just taped a TV special with National Geographic Television.
Oh, really?
Quite a few different channels are going to be doing Einstein specials. And I just finished writing an 8-page spread for Discover magazine for their September issue. So there are going to be a lot of specials heating up later this year and into next year.
You do very well on television.
Oh, well, thank you very much.
You really do. I how do you manage to handle it? TV is so very different than, for example, what we're doing right now. It's a totally different world.
Well, I just try to think like I'm talking to students or talking to a young person. And then you don't want to impress them with big-sounding words. Einstein once said that unless a theory can be explained to a child, the theory is probably worthless. Pictures, physical pictures, is what motivated Einstein. And we now realize that these children's pictures are what, motivates the universe. Pictures that children can understand. And so when I'm on TV, I simply say to myself that I'm talking to a young person.
Well, I must say it worked very well, and I remember seeing you on what was it? I mentioned it to you. It was a kind of an odd channel that I caught you on doing an interview, and I thought, what's he doing on that channel? But boy, was it ever a good interview, and I thought, there is the next Carl Sagan, and I guess you are the next Carl Sagan.
Well, thank you. I try to reach people.
You do. Mm-hmm. You do. That's a very unique talent, particularly in a very short amount of time, to be able to impart, understandably, such complex issues. The nation has to have people like yourself.
Mm-hmm.
So I hope that's a job that you sort of would welcome. It seems like you are.
That's not my main thrust. My main thrust, of course, is trying to complete Einstein's dream.
Yeah.
But it's always good to, tell the public, why are we spending so much effort and billions of dollars to try to complete Einstein's dream?
How old are you now, Doctor?
Oh, I'm getting on. I'm 57 now.
57.
Yeah. Mm-hmm.
At 57, there are some who would suggest that you're past your brilliant time, and there's a sort of a thing in science, is there not, that suggests only the young, the brilliant will come up with Einstein-like insights?
Well, there is a tradition in math and physics that says that the greatest geniuses, the supernova ideas that change everything,
yes,
take place when you're very, very young.
Is that truth, or?
However, other physicists and mathematicians have been productive into their 70s.
Einstein?
Einstein was productive into his 70s, even though a lot of biographers, I think, totally misread his latest work.
A lot of controversy about that, right?
That's right. A lot of people thought that he was over the hill after age 40 or so. And, now we have space satellites, laser beams, gravity wave detectors, high-speed computers that can test many of the predictions that Einstein made later in life that people laughed at because, there was no way to test some of his later predictions. And so that's why, that's one of the reasons why I wrote Einstein's Cosmos, to correct this mistaken opinion of biographers that he was over the hill.
And how were you able to assess in your mind for writing the book that, in fact, he was not over the hill, that some of his greatest insights came later?
Because he was pushing the boundaries of relativity theory. He was getting into wormholes. He was getting into higher dimensions. He was getting into all sorts of research that took him in directions that were totally untestable in his time. Realized the Nobel Prize committee couldn't give Einstein the Nobel Prize for relativity. They gave the Nobel Prize to him for the photoelectric effect, which is the basis of modern television, for example. Television owes its existence to Einstein's theory, because they couldn't get their mind around relativity. It was very difficult to test in his time, and it really wasn't until the atomic bomb was created that a lot of naysayers finally said, oh my God, Einstein was right, E equals mc squared.
Yes. How do you feel about the fact that he made the atomic bomb possible? And for a second, if Mr. Einstein had never lived, how much farther along in history do you think the atomic bomb would have dawned on the world?
Well, many people in 1905, almost 100 years ago, were close to relativity, but they just couldn't make the final leap. I think in another 5-10 years, people would have finally completed the last missing piece of the jigsaw puzzle and said E equals mc squared. But general relativity, which gives us black holes, curved space, the possibility maybe of time travel, that was maybe 50 years ahead of his time. And so for one man to get two of the greatest theories of all time is astonishing.
It is. It is. But 5 years is not a long time. And do you think that's generally true of science, that a discovery is going to be made in a very narrow window by possibly quite a number of people, no matter what? I mean, we just stumble forth?
Yeah, well, great breakthroughs are made when there's a contradiction between the reigning paradigms, and quite a few people were saying that there was a contradiction between Newton's common sense laws of motion and the theory of light, Maxwell's theory of light. But no one could put the whole picture together. Poincaré, Lorentz, Fitzgerald, a lot of them had pieces of it, but no one saw the big picture, that space itself could shrink, that time could slow down. I mean, who would have thought that time itself is not an absolute? That's embedded into our conscious mind.
It is.
You know, if it's 12 o'clock on Earth, it's 12 o'clock on Mars. 1 second on Earth is 1 second on Pluto. But that's wrong. So it took somebody like Einstein to make that leap and to say that a second and a meter stick are not the same throughout the universe. Einstein used to joke that he put a clock everywhere in the universe, each beating a different rate. But in his own life, he was so poor, he could not afford to buy a clock for his own office. That always is going to lead me to my favorite topic, which is time travel. And I guess it's a matter of power, but you don't see time travel, particularly to the future, as an impossibility at all, do you? Well, you know, Einstein was grappling with time travel in his later years. His office mate down the hall was Kurt Gödel, perhaps the greatest mathematical logician of the last 1,000 years. He disproved the dream of the Greeks concerning the foundations of mathematics. But Gödel then, created the first time travel solution, that if the universe rotated, time travel would be commonplace. And so Einstein was really shook up. And in his memoirs, he mentions this. He mentions the fact that time travel was always in the back of his mind when he formulated general relativity, and he wanted to find some way to eliminate it. But here was his office mate already finding solutions that allowed for time travel. Very disturbing.
Why would he take the tack of trying to eliminate it?
It was too much even for Einstein. Here was Einstein, who gave us matter, energy, the secret of the stars, black holes, space warps. Time travel even boggled his mind. But here was his office mate down the hall, who was finding a solution of Einstein's theory for rotating universes that allow for time travel. And since then, by the way, hundreds of solutions have now been found of Einstein's equations which allow for time travel. None of them, of course, are practical, but we physicists are goggle-eyed, realizing that it is a possibility allowed within Einstein's theory. It's something that we cannot dismiss, in other words. We can't laugh at it.
No. I suppose if time travel is possible to the future, then the old question of where are the time travelers is therefore answered, because you can't travel in the past, and we will be around if it's announced, we've managed to get time travel into the future. We'll be there for that.
Time travel into the future is allowed by Einstein's theory of 1905. So that's well established with our space probes. Our astronauts, by the way, every time we send an astronaut into outer space, we actually send them into the future a little bit. Not by much, of course, a fraction of a second. But every time an astronaut goes up in outer space, time slows down for him. So in other words, he is, shot into the future. So in the future, when we get space probes that can reach stars and reach near the speed of light, we'll actually be sending them into the future. So future travel is a reality. We've tested it. The GPS system that a lot of people use to locate their position on the planet Earth.
Sure.
The GPS system would fail without relativity. Pentagon generals have to be briefed on Einstein's theory of general and special relativity because it is so essential for very accurate timekeeping on the planet Earth.
All right, hold it right there, Professor. We've got a break here at the bottom of the hour. We'll be right back. Professor Michio Kaku is my guest.
Talk with Art Bell. Call The wildcard line at area code 775-727-1295. The first-time caller line is area code 775-727-1222. To talk with Art Bell from east of the Rockies, call toll-free at 800-825-5033. From west of the Rockies, call Art at 800-618-8255. International callers may reach Art Bell by calling your in-country Sprint access number, pressing option 5, and dialing toll-free 800-893-0903. From coast to coast and worldwide on the Internet, this is Coast to Coast AM with Art Bell.
Hope you're having a wonderful weekend, everybody. Spooky from Enterprise, Alabama, right? Say, Art. If every time we send someone into space, they travel a little bit into the future, well then how come we can still see them when they come back? And I thought, silly question. Then I thought, no, it's not. That's actually pretty good. We'll ask. A quick note about fast blasting, and that's the ability to go to the website at coasttocoastam.com. I hit fast blast and then type in a message to me, which will then appear on my computer screen at the speed of light. Well, maybe not, but pretty quickly. And the best thing for you to do, and the best way for you to get one of your fast blasts on the air, is to ask a relevant question of some sort of Dr. Kaku. And when I'm looking at Fast Blast during the course of a show like this, I'm kind of looking for that sort of thing. So if that helps you decide what to type out and blast away at me, then so be it. Dr. Kaku, it's kind of a dumb question, but it's not. I mean, if that astronaut has proceeded a second or two into the future, then how are we able to view him when he returns?
Well, we have the science fiction impression that when you go into the future, you disappear and then you reappear someplace else.
Right.
But it's actually more mundane than that. If I take an alarm clock and I throw it into outer space, the alarm clock simply slows down. That's the way we've always measured it with our instruments, that clocks slow down when they go into outer space. You can see the clock, it's visible by telescope, but it simply beats slower. So when the clock comes to rest, and you look at the clock's frame, you find that it's backwards compared to your clock. So if you were on the clock, you basically went into the future. So the clock looks like it's in the past, which means that from the clock's point of view, everything else is in the future. It's like suspended animation. If you were to send astronauts into outer space under suspended animation, right, and you woke them up, they would wake up in the future. But all you've done really is slow down their time. You slow down their biological processes by putting them to sleep in suspended animation. So that going forwards into the future is the same as having your clock slow down. And this has been measured, with our space satellites. The GPS system depends upon it. In fact, all our satellites would be out of whack unless we compensate for the fact that when we send satellites into outer space, we actually send them into the future slightly.
But if we could devise a method with all the power we needed, the power of the sun or whatever, and we could toss somebody forward into 2012, they couldn't be here and in 2012 simultaneously, could they?
Well, if you look at them, they would look frozen.
Really?
So again, if you throw an alarm clock into outer space and you look at it from the telescope, and the alarm clock is moving very close to the speed of light, it looks frozen.
So in other words, if there really was a time machine and I blasted forth to 2012, you would see me as a frozen figure sitting in the time machine.
For that period of time. That's future travel. Now, past travel is much more difficult, and that requires the general theory of relativity. That actually requires warping the fabric and ripping the fabric of space and time. But to go forward in time is well established.
That's so fascinating. Not one science fiction movie has ever depicted it as they should have been.
That's right. You are from here to now, from here to the future, you're frozen, so you look like you are stationary, frozen in time.
Indeed.
Like suspended animation. So when you wake up, you essentially wake up far into the future.
Question. would that frozen figure, if observed over a period of time with a time lapse or something, actually in reality not be totally frozen?
That's right. The person would actually be moving very slowly because the clock, his clock, is slower compared to my clock.
Got you.
So we can see his clock at any time. At any time, we can even touch his clock and see his clock. It's just that his clock runs slow compared to our clocks. So when he finally comes to rest, he's way in the future. So that if we send a starship to the nearest star, 4 light years is what what the distance is normally. It would take 4 years for a starship to reach Alpha Centauri. But for the starman, for the star person in the rocket ship, it may take him just like a minute, a second, to go to the nearest star. And if we look at him with a telescope, he looks frozen throughout his journey, moving very slowly. So by the time he gets to the nearest star, we measure 4 years. He says it's only been 4 seconds.
Huh. All right. You said time travel to the past, a very difficult, much more difficult.
That's much more difficult, right?
But you didn't say impossible, or do you want to say impossible?
No, not impossible at all. In fact, in the pages of Physical Review magazine, there are all sorts of proposals and blueprints being proposed by physicists to go backwards in time. These are solutions that are consistent with the laws of physics. However, I should point out that the main problem with these blueprints is the gasoline. The gasoline necessary to take you backwards in time would be comparable to an exploding star, a black hole. But in principle, yes, Einstein's theory of general relativity has hundreds of solutions which allow for various forms of time travel. Not just the Gödel solution, but we have the Tipler solution, we have Neumann-Unti-Tamburini solutions, we have a whole book of solutions that allow for time travel.
Well, that's pretty spiffy, but that really does then bring on the question, then where the hell are they?
Well, my point of view is if you watch a dinosaur have lunch, the first time you do it, it's quite dramatic. But after you see a dinosaur have lunch a million times, you sort of lose interest. Well, I think pretty much that they've lost interest in us. We're not that unique. We're not that interesting to them. I mean, after all, if you see a bunch of ants on the floor, do you want to, communicate with the ants and videotape the ants? I don't think so.
Well, there have been times, actually, where I have laid down on the floor and watched ants for a while. It's rather intriguing.
And then you get bored.
You do. You get bored.
That's right. I think
but
that's why
they do march along just in single file. It's quite remarkable.
So I think they probably visit us a few times, and after that they say,
you really
been there, done that.
You think we've had visitors?
It's conceivable. I mean, if somebody knocks on your door and claims to be your great-great-great-great-great-great-granddaughter in the future, don't slam the door. It's conceivable that our own descendants, far in the future, may eventually harness what is called the Planck energy and, exploit a hole in space and time and visit you. Again, this is still controversial, but there are physicists who claim that, yes, we can visit our parents before we're born.
Huh. And the age-old question, of course, of doing harm to one of your parents, your answer, as I recall it, is that we create at that instant an impossibility that causes a new bubble, a new universe in which things unfold in a different way?
Yeah, the timeline, the river of time forks into 2 rivers. So originally I have 1 river, and then it forks into 2 rivers. Now, some scientists believe that you get a whirlpool instead of a fork. If you get a whirlpool, then you go backwards in time and simply fulfill the past. So it was written that a time traveler would enter your time frame in the past. Mm-hmm. I don't think so, because then you have all sorts of paradoxes if you have free will and can monkey with the past, right? More and more physicists believe that the river of time simply forks into 2 rivers, 2 quantum rivers, basically, that coexist. And this is the many worlds theory. And quite a few Nobel laureates now are now swinging over to the many worlds theory.
Not to be confused with other dimensions?
Yeah, this is ordinary garden variety, 3-dimensional Twilight Zone type episodes.
Huh.
Remember that episode of Twilight Zone where a man wakes up and finds out that no one recognizes him because he was never born?
Yes.
Well, that's conceivable because one quantum event could cause a miscarriage in your mother. One cosmic ray could cause your mother to have a miscarriage, in which case you were never born. So one quantum event separates two universes. One universe where you were born, and another universe where you were not born because your mother miscarried. One quantum event, one cosmic ray can separate two universes. And, for those of us who believe in the many worlds theory, it means that there are many quantum worlds that we exist with simultaneously.
Okay, I'm a little confused here. In other words, I understand the concept of 11 dimensions, let's say. Are you suggesting that going back and doing something awful would put you into another dimension, or would put you into something else that is not one of the identified or not yet identified 11 dimensions? Well,
these 11 dimensions are dimensions of space. They're dimensions that are beyond human ken. And again, many physicists believe in these things. The dominant physics laboratories of the world work on string theory in 10 and 11 dimensions. Okay.
Right.
Here we're talking about quantum universes. You don't really know where the electron is, right? We learned that in chemistry class. That's why electrons are in orbitals around the atom.
Right.
All of us had to struggle with these darn orbitals when we were in high school. These orbitals are nothing but parallel states of the electron. The electron is in two places at the same time. Now, that's not possible for big people. Electrons do that all the time. It's called electronics. Laser beams are based on this principle, that you don't really know where the electron is at any given time. It's the uncertainty principle. Now, we think that universes also obey this principle. And so if electrons can exist in multiple states, called orbitals, which is the basis of all chemistry is based on uncertainty, this means that the universe is probably also uncertain, and that the universe could exist in parallel states. And there are universes where perhaps, you were not born, or perhaps you had an older brother that you never knew existed. So,
but still part of this considered 11 universes?
No, this would be ordinary three-dimensional universes.
Okay, all right.
Even Einstein, back in 1925, had to grapple with this fact that there could be multiple quantum universes existing with us simultaneously. Steven Weinberg, Nobel laureate, likes to look at it this way. Think of your room where many radio signals are coming in from many radio stations at any given time. One of them carrying, of course, the Art Bell Show. You exist simultaneously with many frequencies. All these frequencies are decoupled. Okay. Now, we believe that if the universe is a wave, that you exist simultaneously with many waves. So that in your own room, there are dinosaurs. There are the wave functions of aliens, UFOs, dinosaurs, alternate universes right in your room, but they have decoupled from our frequency. They're at a frequency that we cannot measure. This is called the many worlds theory. And we physicists are gradually leaning toward the resolution of the paradoxes of the quantum theory via the many worlds theory. So in your room, there could very well be the wave functions of dinosaurs that were never wiped out 65 million years ago that still exist because they split off from our universe.
Professor, is there theoretically a way that man may ever view these parallel concurrent worlds?
Well, at Oxford University, Professor Deutsch has been pushing forward quantum computers. Quantum computers will replace ordinary computers perhaps in a 50-year time frame. Ordinary computers will basically cease to become very powerful after about 20 years.
Well, they do that now on a regular basis, about 6 months.
Yeah, but that law is going to collapse, Moore's law.
How close are we getting to that?
We're getting very close now. 2020, Moore's law should collapse, and Silicon Valley could become a rust belt. Mass unemployment in Silicon Valley in 20 years.
Well, yes, but then they'll be building the quantum computers, and where will they build those?
Well, unless Silicon Valley gets off its butt and starts to do research on quantum computers and DNA computers and exotic forms of technology, they could be left in the dust. There could be a new Silicon Valley forming in 15, 20 years.
Why is DNA considered basis for computation?
Well, think of computer tape. Computer tape consists of zeros and ones, right?
Right.
DNA is computer tape.
Right.
Instead of zeros and ones, it is ATCG.
Right.
ATCG are 4 letters that correspond to 4 amino acids. And so the computer tape would read, instead of 000111111, it would read AAA, TTT, GGG.
But what is so elegant about the DNA configuration that you would see it as the basis for a computational system?
Oh, because these zeros and ones represent numbers as well as instructions. And you can take DNA and let certain segments of DNA equal 0, other segments equal 1. Huh. So this computer tape of ATCG can be transformed into 00110011. And so this is how we take DNA, treat it as computer tape, cut it up, reformulate it, and allow it to make calculations.
Isn't there a little bit of possible danger in doing that? In other words, if you actually created a computer based on DNA, wouldn't you be potentially simulating life itself?
Not really, because these are not self-replicating things. Now, however, there are some scientists who would like to create new forms of life based on a truncated DNA, and potentially that could be very dangerous because they would self-replicate. They would actually, like a virus, they would actually replicate, and it would not be quite DNA. It would be a quasi-DNA, and it would replicate, in principle without limit. So, like a virus. So that is potentially very dangerous.
The infamous gray goo.
Yeah, and this is natural now. We're not talking about artificial.
I wasn't thinking so much of that aspect of it. Scary as the gray goo thing is, I was thinking about, it's the blueprint of life, isn't it?
Right.
And so when you put together a computational machine based upon that, or even a variant of it, then you're toying with being a god, as it seems like.
Yeah, well, you would be playing a god if you could make it self-replicate, that is, reproduce itself any number of times. In a DNA computer, it does self-replicate, but then it stops. Okay, so at the end of the process, you simply have a flask of liquid, and then you simply read the DNA in the liquid. It's not replicating anymore. The danger is if you create artificial life, and it simply keeps on going, it doesn't stop. That could be very dangerous. And remember, Greek gods often lost control of their own creations. Greek mythology is full of folly and jealousy and all sorts of the whims of Greek gods who were not very moral.
I interviewed a scientist, and I can't recall his name, in the last 6 months, who suggested to me that he thought that was going to be the next evolutionary leap, that we were in fact designed to become gods and create that which would replace us.
Well, in principle, but remember the Greek gods were full of folly and full of mischief.
And we're not?
And they were not very wise at all. If you read Greek mythology, Zeus and Mars and those gods created all sorts of mischief. So I would hope that when we become Homo superior, when we make the next leap in our evolution, that we also take with us a dose of wisdom as well, so that we don't get carried away with our own arrogance.
Well, do you think, Professor, that wisdom has a linear movement with evolution? I mean, as we increase our knowledge technologically, do you think that you could chart wisdom going up in a linear way with this technological ability, or would you say that line would be far further down?
Well, I think that wisdom comes from democracy and democratic debate. I think that the more people debate on the Internet and, via the media and via elections, the more the public is educated and then uses that education to vote democratically, the better control we will have over technologies that could spiral out of control. So I think that the main thing is, first, people have to be educated about these things. And second, once they are educated, they can make wise democratic decisions at the polling booth. And so I think that's where wisdom comes from. It's very messy. It goes backwards and forwards. Democracy is quite messy. But I think that's the way to do it, rather than to rely upon a benevolent dictator who we hope will make the right decisions, but 9 times out of 10 does not.
So you are satisfied then that our wisdom is increasing as quickly as our technological capability?
As long as people are educated and participate in the marketplace of ideas. Unfortunately, many people are not educated about these things.
All right, Professor, hold on. Stay right there. One of the greatest minds in the world, Dr. Michio Kaku, he's incredible, absolutely incredible, and he is the next Carl Sagan. He absolutely is. A man who can explain things that others would certainly confuse you with rhetoric. He doesn't.
From coast to coast and worldwide on the Internet, this is Coast to Coast AM with Art Bell.
Isn't it interesting, this song? Have you ever really listened to the words? According to those who wrote it, it's a complete enigma. In other words, it doesn't mean a thing. And yet when you listen to it, you listen to the words, it seems to have deep meaning of some kind. Once again, ladies and gentlemen, Professor Michio Kaku. Dr. Kaku, I would like to read you a couple of quick stories, both from really good sources, and I've got a complaint about science, and this will illustrate it. This one is from the New York Times, May 13th, 2004. In part reads, in the second half of the 20th century, the world became quite literally a darker place. Defying expectation and easy explanation, hundreds of instruments around the world recorded a drop in sunshine reaching the surface of the Earth, as much as 10% from the late 1950s to the early 90s, or 2%, 3% a decade. In some regions like Asia, the U.S., and Europe, the drop was even steeper. In Hong Kong, sunlight decreased 37%. No one is predicting that it may soon be all night and no day, and some scientists theorize that the skies have brightened in the last decade as the suspected cause of global dimming, air pollution, clears up in many parts of the world. Yet the dimming trend, noticed by a handful of scientists 20 years ago, this is the important part, was dismissed as unbelievable. In other words, they had the statistics, they had the science in front of them 20 years ago, and they saw it and said, rubbish! This can't be true! And so they threw it out. That's my complaint about science. Occasionally, a blazing truth is placed in front of a scientist who is invested in some sort of, I don't know, his way of believing what goes on in the world, and these stats don't fit, so they just throw it out. Is that a fair complaint about some science?
Well, I think so. When Einstein came out with relativity, he was met with stunning silence. It took many years for the scientific community to come around to believe in relativity. And I saw that article that you mentioned, and I was rather surprised myself seeing that. Satellites, for example, above the clouds, see no change in the sunlight coming from the sun. However, there's something very drastic happening with the atmosphere of the Earth. And we're beginning to realize that the atmosphere is a lot more quirky than we previously realized. Chaos theory basically tells us that you cannot predict accurately the future weather. The weatherman only gives you the weather, to within a day or so. Everything beyond that is pretty much science fiction. So I think it really shows you that we have to be humble when it comes to the weather. The weather has all sorts of surprises, things that we never suspected, because we only live, for a human lifetime, and we assume that things are going to be constant throughout that lifetime. Well, if you look at the geological record, ice cores from the North Pole, for example, you find there's all sorts of havoc, all sorts of catastrophes and changes, like a roller coaster, the temperature of the planet Earth. And we're just beginning to appreciate that now, that the Earth is a very dynamic place with all sorts of shifts that we really don't know what causes them.
Okay. Well, that's a complaint about science. Now, I also interview many people on this program that deal in the metaphysical or ufology. And here, for example, is a story from Mexico City, and I just bet you probably saw the video, but the Mexican Air Force released footage of what a UFO expert said were 11 invisible, unidentified flying objects picked up by an infrared camera as they whizzed around a surveillance plane in Mexico. A longtime believer in flying saucers told a news conference Tuesday the objects were real, seemed intelligent, in quotes, after at one point they changed direction and surrounded the plane that was chasing them. Now, they appeared on radar, and they, in fact, the Mexican Air Force virtually said, UFOs, we hereby give you this video. They're real. They were pretty shaken up down there. This really occurred. It was on everybody's radar, and in fact, I saw the video. It ran on CNN. It was pretty shocking stuff. And I understand that talking about UFOs to somebody like yourself is probably not the thing I ought to be doing, but this is an important story, Professor, and maybe there are visitors here. Is it within the realm?
Well, I saw the video, too. And it's enough to have, the hairs on your head start to rise up a bit. You see, I would say that 95 to 98% of UFO sightings could, in fact, be explained by, for example, radar echoes or swamp gas, meteors, even Venus, the planet Venus. Has been known to set off UFO alarms.
Sure.
And every time a meteor, hits the atmosphere, lots of people say that they saw a UFO.
Sure.
However, the stories that are credible are the ones that involve multiple sightings by multiple methods. In other words, not just one person saying, I saw a flying saucer by eyesight, but multiple individuals saying that they sighted something by radar, by visual methods simultaneously. And there was a famous JAL flight that we physicists are still looking at because, again, it satisfied all the criterion I mentioned, multiple sightings by multiple means. This episode in Mexico also satisfies that. This is one of the few percent sightings for which we physicists are kind of like dumbfounded. We think we have a pretty good grasp on 95 to 98% of UFO sightings. But it's that last 2 or 3% that really shakes you up. And this is one of them because, it was multiple individuals stating that they viewed this thing by radar, by infrared.
Visually.
And visually. So there were more than one ways in which they saw this thing.
Oh, yeah.
And this thing, of course, was executing maneuvers that simply defy the normal laws of aerodynamics.
Certainly was.
A radar echo, by the way. A radar echo will also seem to zigzag and speed much faster than any airplane because it's just nothing but a reflection off a mountain or something.
What would Occam's razor say about this category of sighting?
Well, I think that it's a category of sighting that we physicists have to take seriously. There are physicists that are friends of mine who take these seriously. They, of course, have to worry about the giggle factor, that their friends will giggle, but they do take these things seriously, believe it or not. And they've looked at hundreds of these sightings, and again, 95 to 98% you can dismiss as being radar echoes, swamp gas, what have you. But a few of them really make you wonder, Now, unfortunately, science is based on reproducibility, so that unless it happens again in a similar way, we can't really say for sure, right? Science is based on reproducible experiments. That's the foundation of science.
Yes.
That's why it's so reliable, because it's reproducible. The UFO sightings are not reproducible. Therefore, it's quite difficult for us physicists to get a handle on this. However, there have been sightings of UFOs that have left, pieces of metal behind.
Well, let's try this. For what you just heard and what you know about the story, I didn't have to read it to you. I know you heard about it and saw it. What would be, if you were pushed, the most logical explanation for what that was?
Well, this sighting does not fit into the usual categories that we scientists have very carefully isolated over the last several decades, starting with the Blue Book Project and things like that. It's something that, again, is something that is beyond what we have a rational explanation for. Now, most physicists would say that the stars are so far away that it's very difficult for an alien to reach the Earth. They're thousands of light years away, and galaxies are millions of light years away. However, like I said before, if you are very advanced at the level of Type 3, galactic civilization, with energies that are galactic, not just planetary, then it becomes possible that you can begin to use Einstein's theory as a playground and really take some of the more far-out conclusions of Einstein and begin to, fold space, begin to create wormholes perhaps, and in which case you wouldn't really even need a flying saucer at all. You would simply need a stargate, basically an entrance, basically what we call a kermetric, in order to open a hole between a distant star and us. So that would get around the argument used by most physicists that the stars are thousands of light years away and galaxies are millions of light years away, and therefore they're simply too far for alien life to reach the Earth.
But doesn't all of this begin to rise to the level of legitimate scientists saying, well, you know what? Maybe we better take this class of sighting and pour some money or some research into what the heck's going on. I mean, it really is something.
That's right. I think this is something, and I think the government should, set aside, a few $1 million is nothing. The government spends a few $1 million every second. So it wouldn't take much time from the government to set up a blue ribbon panel of scientists to look at these things, to offer an explanation, not to squirm, but to offer a explanation, whether it's solid science that there is a way to explain this as swamp gas or radar echoes, or whether this is really something that is beyond the pale.
Certainly it is insufficient to conclude with a gavel at the end of Blue Book way back when, isn't it?
Yeah, I think the Project Blue Book was very political in the sense that the government had an axe to grind. We now know that the government was experimenting with aircraft that were super secret, stealth aircraft, for example, and they wanted the public to not investigate these super black box aircraft.
Probably still true today.
That's right. The military, of course, does have its black arts, and they have DARPA, and the military does have aircraft that is being experimented with that all have different kinds of shapes. Some of them, by the way, even look like flying saucers. I've seen some declassified designs created by the Pentagon. Some of them even look like flying saucers.
Hearing a lot about invisibility these days.
Yeah, well, invisibility is something that we physicists don't have much of a handle for. Radar invisibility we already have. That's stealth.
Right.
But stealth is nothing but a hodgepodge of little tricks to disperse the radar. So the radar bounces off an aircraft and disperses, so it doesn't come back.
I meant optical.
Yeah, optical invisibility is beyond physics. It would require a new level of physics to become invisible. We do believe that dark matter and dark energy are invisible, that most of the universe is invisible. But we physicists don't know how to manipulate dark matter. Or we don't even know what dark matter is, other than the fact that we can reproduce it with the Hubble Space Telescope, because dark matter distorts light beams. So most of the universe is invisible, is dark. But we physicists don't know what it's made out of. So an advanced civilization that could handle and manipulate dark matter could create invisible matter, basically, matter that has weight but is invisible. So that would be quite fantastic.
Indeed. Jeremy in Phoenix, Arizona asks, what current scientific project are you currently watching most closely?
Well, my specialization is string theory and M theory. And M theory goes through, every 10 years, goes to a revolutionary change, which changes the whole landscape. But we're getting closer and closer to that one-inch equation. So I scanned the literature to see whether anyone has a handle on being able to, summarize the power of this theory. This theory was discovered by accident. We were not supposed to see this theory for another 100 years. We got a sneak preview of the theory of the future because it was discovered quite by accident. And so I scanned the literature to see whether there were any breakthroughs in this field. I also scanned the literature to see whether there are any breakthroughs in nanotechnology. However, I personally believe that Prince Charles and other individuals have exaggerated the threat of nanotechnology. We're nowhere near getting a gray goo that could swamp the whole universe. But it's always good to keep up with what's happening with nanotechnology because, that will be the future. There will be atomic machines. There will be machines that are, smaller than a cell. And this could, in the future, decades away, not tomorrow, but decades away, it could create a second industrial revolution.
Well, you said that quantum computing wasn't that far away. When we get quantum computing, Professor, what will it bring with it?
Well, the CIA has looked very carefully at quantum computers because they could crack any computer code, any encrypted code, much faster than any known computer. So, however, I should point out that the most advanced quantum computer could only compute on about 7 atoms. It multiplied 3 times 5 is 15 last year. That's the world's record, by the way. Kids know that 3 times 5 is 15. But a quantum computer did that last year. That's how primitive the technology is. And instead of 7 atoms, you want to calculate on perhaps, a few thousand to million atoms. So you see how far we have to go.
Sure, but you're still saying we're going, even if it's decades, that's not that far. But when we get a fully functional downtown type developed quantum computer, what would we be able to do with it, potentially?
Well, one potential is to reproduce human thought. The brain is not a digital computer. There's no Microsoft Windows for the brain. The brain has no CPU. It has no Pentium chip. You can lose half your brain and the brain still functions. The brain is a neural network. The brain is a learning machine. It is not a computing machine. It is a learning machine. Learning machines rewire themselves constantly, and quantum computing may eventually give us the ability to duplicate the fantastic capabilities of the human brain. And speaking of brains, by the way, you know that Einstein's brain, to get back to the subject of my book, Einstein's Cosmos, Einstein's brain is back at Princeton now, where it belongs. And so it's now at a place where scientists can really study it.
Have we yet found anything abnormal about Einstein's brain? Or does it appear, is it larger? Is there anything about it that we've discovered yet that places it in a different category?
Yes, there is something unusual about Einstein's brain.
Oh?
Well, first of all, the person who performed the autopsy went against the wishes of the family. He wanted to be cremated. And he basically stole Einstein's brain and kept it in his office for many, many years. And it's been floating around the United States for many years.
Really?
And now it finally is back at Princeton where it belongs. It's in several pieces. Much of it is sliced up into view graphs that can be seen by microscope, and other parts of it are in chunks. There is one part that is unusual. The brain looks very normal, but there's one part that is actually not normal. It's the part of the brain that involves abstract thought. It is much thicker than in the normal brain. Now, my personal point of view is that this means that genius is probably not born. Genius is probably made. If you get mice brains, for example, you train mice to do certain tasks.
Yes.
And then you analyze the brain. You see that the brain is slightly changed. The brain actually rewires itself, grows in certain directions to consolidate certain new tasks that it has just learned.
You're saying geniuses are made, not born?
Probably. In other words, Einstein was not a child prodigy. There's no instance where he dazzled his parents with mathematical ability as a child. He was actually kind of a slow learner for much of his early life. But he had the ability to think in terms of simple pictures that grasp the essence of phenomena, and he could stay with these children's questions for like 10 years at a time, like what is light, what is space? He would stick with these questions for 10 years before he could finally crack them. And so I personally think that composers, musicians, mathematicians, people involved in abstract thought, that part of the brain is going to be accentuated just because the brain rewires itself after you learn certain tasks. Now, most of us never do that. Most of us never ask children's questions and then spend 10 years trying to answer them.
Do we have any idea what in Einstein's life made him what he was?
Well, we have instances where, clues. When I was writing Einstein's Cosmos, my latest biography of Einstein, I realized that a compass needle, when he was around 10 or so, fascinated him. And when I interview other scientists, they all see the same thing. At around 10, 11, 12, those are the magic years before they hit puberty, 13, 14, and then they're lost, right? But while they're still 10, 11, 12, those are the magic years when they realize that the world is much bigger than mommy and daddy. The world consists of a universe.
The magic years. All right.
I think.
Hold it right there. We're at the bottom of the hour. Let's pick up on that. The magic years. I wonder what happened to Albert Einstein during the magic years. What was the trigger? If it really was environmental and he wasn't born that way, then what environmental trigger turned Albert Einstein into the man he was? I guess that's the big question.
From coast to coast and worldwide on the Internet, this is Coast to Coast AM with Art Bell.
It is, and my guest, of course, Professor Michio Kaku. The magic years. How about you? Do you remember what you were doing in your magic years? Some environmental trigger then changed Einstein from the normal little 10-year-old to one who begins to think of things that the rest of us simply don't. I have vague memories of what I was doing around 10, and I won't embarrass myself by telling you. Magic years, around 10 or 11 or 12, right in there. Well, all right, fine, Professor. So you believe an Einstein is environmentally launched as opposed to born that way. What kind of environmental trigger can you imagine? And I know you've looked into it. With that theory, you would have had to have looked into it. What was his life like? What might have done the trick?
Okay, I think there are two basic ingredients that create these supernovas, like Albert Einstein, that just light up the universe. The first is, during these magic years, 10, 11, 12, 13, before they enter puberty in junior high school and the conformity that we see in junior high school, there's an existential shock that they feel, seeing that there's a universe beyond mommy and daddy. With Einstein, it was a compass needle, realizing that there was unseen forces that were invisible that was guiding the compass needle. For Enrico Fermi, Nobel laureate, it was a gyroscope, realizing the gyroscopes did not fall the way that they normally should fall. For Nobel laureate Steve Weinberg, it was a chemistry kit, learning that there are all these laws of chemistry that you could master right in your own backyard. With Nobel laureate Isidore Rabi, it was an astronomy book, realizing that there are whole worlds out there beyond mommy and daddy, whole worlds out there. So that's the shock. The first ingredient is a shock they feel, realizing there's a whole new universe beyond the home and the family.
All right, Dennis, just before you go on, Dennis in Dallas, Texas writes, if there is a trigger, it has to do with relationships. Einstein understood that the fabric of family would limit his theoretical horizons. He was not held down by family ties. His genius was allowed to fly. Much of our energy is tied into family ties. Agreed?
Well, that was a little bit later. Because in the early days, of course, Einstein was very much tied to his family. His father was an electrical engineer, a failed businessman. It was only later that he just burst forth and went on his own and, became a pioneer all by himself. But I think the second ingredient is you need a role model. You need a mentor, somebody who guides you along. Sometimes that's mommy or daddy. But for Einstein, it was actually a medical student who came by and, tutored him a bit and gave him textbooks. And every week they would do a different textbook, and you kept getting more and more advanced. And pretty soon Einstein was devouring material that even he didn't understand. So it requires a guiding light, a mentor, a role model. The role model, of course, doesn't have to be a family member. For me, it was Einstein himself. Reading books about Einstein, that was my role model. For other people, it's a relative, perhaps an engineer or a scientist or a teacher in the family who gives you books to read. And that is the second thing, the second booster rocket, which then launches you into a realm of thought, a realm of mathematics, and a realm of physics. And this means that children that we see around us could become another Einstein if they have the right temperament and the right opportunity. But unfortunately, most of us don't have the temperament, and most of us don't have the opportunity to launch off into these abstract directions. But I firmly believe that genius is made, not born. There's nothing in Einstein's brain that makes us believe that there is a genius brain.
But if it's not developed during the magic years, then it's probably not going to happen. If it has developed, it's going to stay with you. So, for example, Professor, do you still feel as though you have the ability to move in the realm of such abstract thought that you might stumble across that equation or some other great discovery yet in your life?
Well, we all have that hope. We physicists and mathematicians are productive into our 70s. The brain does not degenerate. The brain is just as sharp as it is in the 70s as it is when you're a youth. The problem is that as you get older and more established, you have more distractions, more committee work to do, more letters to answer.
Yes.
That's the problem. You don't have time to concentrate because when you're young, there are no distractions. You're not married. You don't have kids. You can just concentrate on one thing and just blast off and create great discoveries. So Einstein later in his life had many distractions, but even then he was still productive. He was productive till the day he died. His unfinished manuscript, he was working on his unified field theory, even on his deathbed practically. And so that, I think, is an inspiration that if you take a look at the history of mathematicians and physicists, they're quite active into their 70s. Maybe not as spectacular as they were in their 20s when they won when they won the Nobel Prize, but still very active, very productive even into the 70s.
Eugene in Santa Barbara asks, is it true that before Einstein died, he did state a belief in a higher power? I believe he said, quote, "How could there not be," end quote?
Well, throughout Einstein's life, he had a belief in God. In fact, when he was a teenager, he actually got very religious all of a sudden until he began to read astronomy books and science books and then began to realize that many of the tales that he was told probably violate the laws of science. But Einstein made a distinction between two types of God, and this is very important. The first is the God of intervention, the God that parts the waters, the God that walks on water, the God that answers prayers, the God of Isaac, Moses, and Jacob. That's the first God. The second God is the God of Spinoza, the God of logic and reason and harmony. And so Einstein believed that the universe was so gorgeous, it was so elegant, that only a few equations could describe most things around him, that he thought that there was a God. He called him the old man or the old one. In his writings, he often refers to the old one. And his goal was to read his thoughts, to read the thoughts of the old one, and to figure out whether or not the old one had a choice in making the universe. So when he woke up in the morning, he would ask a question that most of us don't ask. Most of us ask the question, where's breakfast? When he woke up in the morning, he said, I am God. I am going to create a universe. What universe would I create if I were God? And that was his guiding light for much of his life. He would ask himself the question, the universe that I would create would be simple, elegant, pictorial, based on a few physical principles, rather than a jungle of just pure mathematics.
Professor, do you think that Einstein's God of logic, reason, and harmony did he believe that this God would provide a life after physical death for him?
I don't think so. In his will, he said that he wanted to be cremated and have his ashes distributed by his family members. And basically, he, in interviews in his latest years, showed that he was, satisfied with life, that he did his share. He said he's done his share and it is time to go. That we all have our run on the planet Earth, and after that we should go gracefully, rather than trying to, cling to something that is not tenable. He realized that there is a time to go. But he did believe that we're all part of a cosmic order that could not have been by accident. And, we physicists, when we look at the universe, realize that it's very finely tuned. This is called the anthropic principle. The constants of the physical constants, the speed of light, the mass of the electron, the lifetime of the proton, all of them are very finely tuned to allow for DNA to exist and for intelligent life to be created. Now, whether or not that means that the universe was created just for intelligent life, we can debate. But it is quite remarkable that the universe is so harmonious and the physical constants are tuned in some sense just precisely to allow for life. If the physical constants were not tuned so precisely, then protons would be unstable, our atoms would disintegrate, and DNA would never get off the ground, and we wouldn't be having this fun conversation.
Professor, if just prior to your physical death, you were offered the opportunity to virtually be downloaded into some form of computer that would allow your consciousness, your brain to continue to exist in a machine, would you avail yourself of that opportunity?
I might. I think in the future, when we do have quantum computers and we do have fantastic computing ability, it may be possible to download our physical thoughts into a machine. This, of course, is not going to happen in this century. But beyond that, there's nothing in the laws of physics or mathematics to prevent that. Some people, like Hans Moravec, believe that we could do that neuron for neuron, that as we age, neuron for neuron, duplicate that transistor for transistor.
Yes.
So we wake up one day and we find out that we're inside a robot, and we live forever. We become immortal. Other people say that perhaps intelligent life in outer space, they've already done that. Who's to say that when we meet aliens from outer space, if and when that happens, they have to look like us? They have to look like three-dimensional, physical, biological beings. They could be part mechanical and part biological. There's no reason why a carbon-silicon merger cannot occur. We have the world of carbon, that is biology. We have the world of silicon, that is cyberspace and computers. And there's no reason why in the future there can't be a merger of silicon and carbon.
Well, that would certainly allow for trips in space at or near speed of light, which might be practical because you would have an ageless intelligence driving the machine.
That's right. We would be immortal. My only reservation, of course, is that with immortality comes stagnation. We don't want to stagnate. Most of our personalities are pretty much fixed by the time we're like 17, 18 years of age. We don't really change much in personality after our teen years. So I would hope that stagnation doesn't set in once we start to entertain thoughts about immortality. Again, I think that perhaps our children and grandchildren will have an extended lifespan using DNA research, but on a scale of 100 years, 200 years, it may be possible to, as you mentioned, create, cyber immortality, so that our thoughts and our dreams, still exist long after the normal physical lifespan.
Yes,
that's well within the laws of physics.
I certainly wonder if the human brain could sustain without becoming literally bored to death or itself just going insane in not being able to, on a spacecraft, perhaps would be certainly a wild example, but without the ability to continue to think and encounter new things and contemplate new things. Without that ability, it might be unsustainable.
Well, our astronauts in outer space, when they go there for long periods, from months to almost a year, some of them almost go nuts unless they have contact with new ideas, new thoughts. Our brains are learning machines, and when we don't learn anymore, we begin to get very bored and suffer all sorts of depression. And mental illness is a real problem in outer space for prolonged missions. And so I think that will be a problem, that we have to always face new challenges, or else we will stagnate. But again, I think that our children and grandchildren, via DNA research, could expect to extend their lifespan. I think that's conceivable within another generation. And within several more generations, it may be conceivable to, create immortality itself. There's nothing in the laws of biology or physics to prevent it. And our brains don't necessarily age that rapidly. As I mentioned, the body ages quite rapidly, and by the time you're 80 years old, you can barely walk. But your brain, unless you have Alzheimer's or Parkinson's, your brain is rather normal in terms of its ability to function. Mental abilities keep on going much longer than the physical body.
Yes. It's an incredible future to contemplate. And that's where the people on the metaphysical side just refuse to consider science, and science so much refuses to consider the metaphysical. And I think there is some possibility that eventually the two will merge or find some common ground, but it's not anything that's going to easily happen. As I hear these statements from scientists and I hear the metaphysical people scoffing at science, they seem worlds apart, and yet they may be moving toward the same end game.
Well, let's hope that it's like your left hand and your right hand. You know, your left hand or your right hand can argue as to which is more superior, but it really does help to have both dimensions so that you can grasp objects, you know, in their entirety. The brain, of course, has two halves, and there is a more spiritual part of the brain. There is a more analytical part of the brain. Let's hope that the brain functions as a unit rather than having two separate pieces that war with each other.
How much of our brain do we really use?
Well, we now realize that most of the brain is unconscious. The conscious part of the brain is only the tip of the iceberg. When you walk into a room, you scan the room, you figure out which direction is up, down, you figure out the objects in the room, you figure out there's a carpet, a floor, left, right. That requires an enormous number of calculations, trillions of calculations that you're not even aware of, because Mother Nature didn't want you to be aware of it, or else you couldn't hunt, you couldn't find mates, you couldn't survive. We'd be paralyzed realizing how many calculations our brain was performing. And so the conscious part of the brain is actually the tiniest part of what the brain actually does. And we now realize people who work in robotics, in artificial intelligence, realize that, you know, solving algebraic problems, that's actually easy for a computer. The hardest part of a computer is to duplicate the unconscious mind, which we use when we walk, when we navigate, when we sit down, when we analyze three-dimensional space, and common sense when we talk to our fellow humans and gossip about our fellow humans. These are things that are far beyond the capability of computers, because computers are writing machines.
Well, are we actually able to measure the amount of our brain that is active? I assume we can look at electrical activity, or do you think we are not told the whole story? I mean, I hear, we only use 10% of our brain and all the rest of it. Can they measure?
Well, we don't know. We just know that the conscious part is very small. No one's ever proven that 10%. I've heard it so many times. No one has ever proven that. The brain computes at roughly 500 terabytes a second. Roughly, you can calculate the speed at which thought takes place.
500 terabytes
per second. However, the brain is a parallel. It works in parallel.
Right.
It's a parallel processor, and it is a neural network. The architecture is different from a single processor like a Pentium chip. A Pentium chip only says 1 + 1 is 2 sequentially. Your brain calculates simultaneously. Your brain analyzes your heartbeat, the temperature of the room, the balance of the body, all simultaneously, requiring trillions of calculations. And so the brain is really a parallel processor, and it's a neural network. It's a learning machine. And so it's quite difficult to compare it to silicon. Silicon is much faster, but there's a bottleneck, and that bottleneck is the Pentium chip. You know, all calculations have to go through that one Pentium chip, which calculates 1 + 1 is 2. And our brain has no bottleneck. That's why our brain is quite slow at the neural level, but as a whole computes much faster than digital computers.
And that's why in the DARPA race, most of the vehicles pooped out pretty quick, huh?
That's right. The smart truck, the smart soldier, they were all mentally retarded. They had the use of a cockroach, a retarded cockroach. The military had billions of dollars trying to create the smart truck, you know, the intelligent truck that could navigate all by itself. And it had the intelligence of a cockroach. And so we now realize the brain is much more sophisticated than we previously thought. And it will take decades, a good chunk of a century to begin to approximate the functions of what, sits on our shoulder. With the sits on our shoulder is the most complex object known to nature out to 4 light years of the sun. We're talking about the most complex object known to science.
All right. Professor, hold it right there. I wonder if we can create more Einsteins. What do you think? We're going to open the phone lines shortly and allow you to ask any question you want of Dr. Kaku in the middle of the night, which is exactly where we do our best work. This is Coast to Coast AM. I'm Art Bell.
From coast to coast and worldwide on the Internet, this is Coast to Coast AM with Art Bell.
That's what it is. And, of course, Dr. Michio Kaku. Good morning, everybody. I hope you're having a grand weekend, what's left of it, as that timeline continues to move inexorably forward. We're going to go to the phones with Dr. Kaku in a moment, and I trust you have good questions. You always do. Stay right there. If you have enjoyed listening to this brilliant man, then surely you will enjoy his books. And there are many to choose from. Hyperspace, A Scientific Odyssey Through Parallel Universes, Time Warps, and the 10th Dimension. Visions, a very, very popular book. You can look that one up. How Will Science Revolutionize the 21st Century? And now Einstein's Cosmos. Professor, if we wanted to create more Einsteins in the world, how would we change the world if we had that power? And maybe we do, I don't know. But, I mean, what would we do socially to set up a situation where the world was gifted with more Einsteins?
Well, I think there are definite lessons to be learned from his life. I think that, the years before puberty are very important, that we should encourage a fascination with telescopes and chemistry kits and compasses, gyroscopes,
yes,
planetariums, whatever, before they hit junior high school. And by the time they hit high school, of course, science is literally crushed out of them. Any interest in science turns to rote memorization, which is brutal, and they cease to have any interest in science at that point. And then also mentors, role models. We need to have more adults take interest in our kids, cultivate an interest, so that they see that being a scientist or becoming the next Einstein is not such an abstract thing. We have to have mentors for these people to nurture them, to identify them. And then, of course, it's a question of temperament. Not everyone has the temperament to sit down and plug through the math and spend hours and hours and years struggling on a few key problems. So not everyone has a temperament. But I think those are the 3 key ingredients. One is the fascination with science that you can encourage before puberty, and then having a mentor to guide them through puberty, and then, the encouragement that we need from the larger society to make sure that these people continue to grow, and the temperament, of course, has to match.
From a scientific point of view, Professor, would there be a way to identify the possible or even probable Einsteins and segregate and treat them in a more favorable way to encourage this? Would there be a way to do that?
I think so. When Einstein was young, the other kids used to make fun of him and called him a nerd, of course, in German. And today, in high school, we have this upside-down world where the nerds are at the bottom of the social totem pole.
Yes.
But in real life, look at the Bill Gates of the world. The wealthiest men in the world do not look like movie stars. The wealthiest people in the world are, if anything, a little bit nerdish. And so I think that in high school, a lot of kids have this upside-down opinion that you have to be this football jock in order to get the girlfriends, when in reality, it's the people who are smart and ingenious who are the ones who do well on Wall Street, who do well at law firms and amass huge fortunes. So I think that, unfortunately, our educational system is upside down, that in high school, we enforced this fantasy world where if you're very good looking and have lots of muscles or what have you, then you're going to be the top of the ladder. So I think that a lot of, nerdish people drop out of science at that point. They give up, and they say, why bother to struggle? I'm always going to be at the bottom of the totem pole.
Yes. Yes,
so
I'm sure.
I don't think it has to be that way, because, in some sense, most of us are nerds, How many of us are football stars, after all, right? Most of us are not football stars. I have nothing against football stars. I'm just saying that the social totem pole in high school does not reflect society as a whole.
But on the other hand, if the nerds suddenly got the babes, they might be so distracted that they'd never become Einsteins.
Yes, that's a problem, too. If the nerds get the babes too early, they have to get the babes later in life after they've created relativity theory and quantum mechanics.
Exactly.
Right? If they get them too early, then they lose all interest.
Professor, look, I'm going to bring you back here because I can't help myself. I just feel it's in you to do this. Carl Sagan had a series. If a large television network came to you and wanted you to do a series like Carl Sagan, in which you explain the kind of things that you talk about on this program and others, is that something that you would do?
I'd be tempted to, yes. When I was a child, it was so frustrating realizing that there were no good TV programs, there were no good textbooks. I wanted to learn about the fourth dimension. I wanted to learn about hyperspace and things, but there was nothing available to me as a kid, so I had to seek it out. So I think that if there were science specials on the level of a Cosmos series,
yes,
then another generation of young people could aspire to become the next Einstein.
I mean, after all, that would be the mass mentoring that you could achieve, which would be a big, big mark. Who knows how many Einsteins you might set on path. And so I'm anxious for that to occur because I think we need it.
Yes, but realistically speaking, it takes a lot of money. It's a pretty coin to create a gigantic TV special with special effects and computer animation and stuff like that will really dazzle the young kids, right? You have to compete against all the other stuff, the cartoon shows and the fantasy shows on television. But I think it's possible, and, if a big television company were to offer that to me, I'd be very tempted to do that.
Great. It'll happen. Mark my words. To the phones we go. First-time caller line, you're on the air with Professor Kaku. Hi.
Yes, how are you doing?
Doing all right, sir. What's up?
Hey, my name's Andrew, and I had a question. He was talking earlier about time travel. I'm by no means like a Star Trek fan or anything like that, but he sparked an interesting concept by saying that your body would be intact, like frozen at a point. I was wondering if there's a difference between a biological clock and quote-unquote real time, I guess, of what he was talking about. And, in fact, if time travel is feasible, is that inevitably a source of, fountain of youth or some rather?
Okay. I think I've got that straight. Professor, it's not a fountain of youth, is it? The biological clock continues to tick at the regular pace?
Well, your brain slows down. So even though you will live to be, let's say 1,000 years, it appears as if you had an ordinary lifetime. So it is a fountain of youth, but it's an illusion because your brain and bodily processes also slow down. Now, in the old days, we used to think that the biological clock and the physical clock were different, and that's why many people missed relativity in 1905. What Einstein said is that they are really the same clock. Time itself slows, and with it, all biological processes slow at the same time. I once saw a science fiction movie where Earthlings were rocketing at the speed of light, and they looked at the wristwatch, and the wristwatch was stopped. And then one gentleman says, "Look, Einstein was right. My wristwatch has stopped." Well, that's not possible because your brain also slows down at the same time. So you cannot enjoy the fact that you can now live to be 1,000 years of age.
All right. Wildcard line, you're on the air with Dr. Kaku.
The physics major at the University of Nebraska at Kearney. This is a very...
Eric, I'm going to have to eliminate...
The physics major at the University of Nebraska at Kearney. This is a very...
Eric, I'm going to have to eliminate your last name there, but welcome to the program anyway.
Thank you.
And turn your radio off, please.
Okay.
That's a must. We have a 6 or 7 second delay here, and it's horrendously confusing. Okay.
All right, the radio's off now. This is such an honor for me to be able to talk to some professor as esteemed as Dr. Kaku. Thanks for the opportunity for me to be able to do this, Dr. Bell.
I'm not a doctor. I'm just Art. Anyway, go ahead, sir.
Okay, Dr. Kaku.
Yes.
I have read a couple of things on string theory, which you have had a very huge hand in creating.
That's right.
I myself am currently helping a physics professor by the name of Dr. Teresa Marcus here in Kearney, Nebraska at UNK, some educational research on learning physics. And what we're doing is we are looking at the way students learn physics in lecture-based classes and the experimental activity-based courses where students are pretty much in lab all the time, mixed in with lecture occasionally, seeking out and learning the concepts of physics with their own two hands in their own mind in groups. But my question for you is, what are some of the applications that they've come across with in string theory, and how can some of the concepts of string theory be applied to everyday life, for example, in explaining like the acceleration of a sports car, or explaining why objects fall down to the earth the way they do off of tall buildings, et cetera, et cetera?
Well, first let me say that the interactive way of learning physics is the way to go. So often in physics courses, we crush interest in physics out of them because we just teach them a bunch of equations, and we learn about friction and pulleys and things that were, science fiction 300 years ago, but today are of no relevance to modern society. So we teach physics incorrectly. We really teach it like it was 300 years ago, rather than the way it is today with space satellites, laser beams, atomic bombs, reactors, and things like that. And second of all, string theory is really a theory of the future. It's not a theory that's going to give you better colored television or better baseball bats. Isaac Newton and Maxwell's equations are very good in terms of getting you better colored television and better laws of motion. However, string theory is a theory of the universe. It's a theory. Each solution of string theory is an entire universe. And we physicists are trying to find our universe among the many universes that are predicted by string theory. There are millions of these universes that have been found. So far, we haven't quite found our universe yet. That's why, of course, we're not getting phone calls from Sweden, Stockholm, saying that we won the Nobel Prize yet. But we're hot on the trail. So in other words, all physical reality may eventually come from string theory. So where does Newton's laws of motion come from? Where do Maxwell's equations for light come from? All of it may eventually come from string theory. So even though string theory is not going to get you better color television, it makes television possible because it makes atoms possible. Physical reality itself is possible because we think of string theory.
That kind of sounds like an ad on TV. We don't make the floor, but we make it stronger.
And we make it possible. We make physical reality possible. Otherwise, atoms would dissolve.
East of the Rockies, you're on the air with Dr. Michio Kaku. Hi.
Good morning. Thank you for taking my call.
Sure.
I'm afraid my question is going to be kind of simplistic compared to that last one, but I hope you'll bear with me.
Fire away.
Dr. Kaku, I really enjoy your books, and as a quick plug, they're wonderful books for non-scientists. I'm certainly a non-scientist. What I'd like to ask you is in regards to the moon. We've heard some other guests make some very fantastic claims about our satellite, and I was wondering if you could give us a physics-based reason as to why the moon has no rotation.
Well, the moon is in lockstep with the Earth, similar to the way Mercury is in lockstep with the sun because of what are called tidal forces. Now, when you look at the moon, it's always the same moon. It's always old man moon, old devil moon. You've never seen the backside of the moon. And when the Russians, in fact, took a picture of the backside of the moon, it created quite a sensation because we've never seen the backside of the moon, which is quite different from the front side of the moon. And the reason for that is tidal forces. You see, because of tidal forces, the moon is not actually round. It's slightly football-shaped. Not by much, of course. We're only talking about a few feet. But it's slightly football-shaped. And the most stable configuration of a football going around the Earth is to have one end of the football always point toward the Earth. This was shown, by the way, first by the mathematicians of Napoleon. Napoleon's mathematicians were quite advanced in Newton's laws of gravity, and they were the first ones to demonstrate the fact that the stable moon is a moon with one side always facing the Earth. So then why don't all moons have one side facing the Earth? Well, Mercury is very close to the Sun. It is almost synchronized, but not quite, to the Sun. And it takes, of course, billions of years for tidal forces to slowly synchronize the moons until they match that of the Earth. By the way, because of tidal forces, the moon is also leaving the Earth. We're privileged to be alive in an era when we still have a moon. The moon is actually leaving the Earth, not very fast, of course, I think a few inches every year, but over millions of years it does accumulate. So because of these very tiny tidal forces due to gravity, one side of the moon always faces the Earth, and also the moon is gradually leaving the Earth.
Professor, we'll follow up on that. How important to life here on Earth is the moon?
Without the moon, the Earth would tumble over a period of millions of years. Computer programs, you can show using Newton's laws of motion that without a moon, the Earth's axis will eventually tumble, which means that the weather will go absolutely bonkers and life will be impossible on the Earth. Now, Mars has small moons, which means that Mars probably did tumble in the past and will tumble again. In which case, the weather on the Mars will also go very crazy when that happens. So we are lucky to have a moon that is large enough to stabilize the motion of the Earth so that the Earth doesn't tumble and north and south then begin to tumble in outer space, making life impossible.
So the moon is absolutely essential to life, and without the moon, we would not be here.
That's right. And also, for that matter, Jupiter. We need a Jupiter because Jupiter's gravity flings comets into outer space, cleaning out the solar system. Without Jupiter, there would be comets hitting the Earth right now, and without the moon, the Earth would be tumbling in outer space. So we realize that the solar system that we have is rather finely tuned to make life possible.
Yes. It's so interesting. You look around, and everything is exactly the way it has to be for us to be here right now.
That's right.
Some of us attribute that to the hand of God, making everything so perfect, but then that's how we would observe it because we are here. It's just a fact that we're here, and so doesn't that make us automatically think there's a maker? How could we not think that there's a great intelligence behind it, but it could simply be a product of evolution? Of course it's perfect, otherwise we wouldn't be here.
Well, there are two ways you can look at it. One
Yes.
is you could say that in outer space there are dead planets. There are planets without moons. They do tumble. They have no life. They have elliptical orbits, so they don't have liquid water, and so there are dead planets out there. So when we look at outer space, we've identified over 100 dead planets now circling stars. They're Jupiter-like, so we don't think there's any life on them. And in fact, most of the planets that we've seen so far are probably dead planets. So on one hand, you could say that there are just lots of dead planets, and we happen to be on one where life is possible. The other way to look at it is that God exists, and that God created the Earth just right with enough liquid water in the Goldilocks zone from the sun, not too close, not too far, and with circular orbits so we don't crash into each other, with moons to stabilize the spin, with Jupiter to clean out the comets. All these accidents because God loved the Earth.
Yeah.
So there are two ways to look at it.
There sure are. They're probably about to announce life on Mars. They're finding methane and all kinds of things now, water and things that really lean toward, guess what, folks? There's life on Mars. At some level, perhaps a much lesser complex life, but indeed some kind of life on Mars. If they announce that, will you be surprised?
Well, liquid water is where you look for, and water is underground in Mars. And if I were a Martian and I realized that my atmosphere was thinning, that the water was going to the polar ice caps and underground into the permafrost, if I realized that, where would I go?
You'd follow the water.
I would go A, into outer space, B, to the ice caps, C, underground.
Right.
Now, our space probes do not land on the ice caps. It's too dangerous. Our space probes cannot go underground because it's too difficult. But if you really want to look for life, that's probably where life would be, is in the ice caps and underground.
But you won't be too surprised if they find a less complex life on Mars.
Yeah, I wouldn't be surprised. With all the arrows indicating that the conditions for life are possible, that oceans once existed the size of the United States, then yeah, it's very conceivable that life may have started on Mars.
Hold it right there. We'll be right back from the high desert in the middle of the night. What a brilliant mind. Dr. Michio Kaku. I'm Art Bell.
From coast to coast and worldwide on the Internet, this is Coast to Coast AM with Art Bell.
Good morning, everybody. I am Art Bell, reminding you one more time that next week I'll not be here for the weekend. I'll be in New York for the premiere of The Day After Tomorrow, joyously taking it in. It should be really something. And I will be back the following week. Just keep that in mind. If you want to get in touch with me by email, speed of light, minus, I guess, a few electrons getting clogged in servers along the way. It's artbell at AOL.com or artbell, that's ARTBELL, at mindspring.com. Both will come my way. Couple of quickies for you, Professor. I had a guest on last night who was documenting, or seemed to be documenting, an increased energy output in our planet and all the other planets we're able to be observing in various forms, but an apparent increased energy output resulting, for example, in global warming, the melting of the ice caps on Mars, and he gave many other examples. Is there any indication that that's going on?
Well, it depends on what form of energy. Energy can be electromagnetic, energy could be nuclear, energy could be gravitational, and there are many frequencies of energy as well. If you could be more specific, perhaps we can then analyze the spectrum of energy being emitted. But global warming, as you mentioned, that already takes place on Venus. So we know that global warming is a fact of life. The temperature of Venus is 900 degrees Fahrenheit, hotter than a baker's oven. And it's actually hotter than Mercury. Mercury is the closest planet to the sun. But Venus is actually hotter on average than Mercury because it traps sunlight because of its carbon dioxide atmosphere. And carbon dioxide alone, without any extra radiation, is sufficient to trap sunlight on the planet Earth. And every major glacier on the planet Earth is receding, and the polar ice caps are only 50% as thick as they used to be.
It's incredible what's happened to them. Absolutely incredible.
The snows of Kilimanjaro will not be the snows of Kilimanjaro in another generation. The Alps, it'll be impossible to ski in the Alps in perhaps another generation or so. And, huge chunks of ice the size of Delaware are breaking off the South Pole. And the largest ice shelf in the North Polar region cracked in half just a few months ago. So we're seeing things that I thought I would not see in my lifetime. I mean, I was aware of global warming years ago, but I didn't think I would see it in my lifetime.
There was a chief scientist in Britain who just said that rapid climate change is a bigger issue and should be to the world than the threat of terrorism or anything else, that the possibility of a rapid climate change should be looked at as one of the biggest national security risks we face.
Yeah, I think it's an insurance policy. With just a few more $1 million extra funding, you could get a hell of a lot more information about what could plunge the entire Earth into a deadly, absolutely devastating era of climate change. And like I said, it's happened before. It's not science fiction. It's happened before. We see it in the geological records.
Right.
And right now, for example, the very fact that we're speaking to each other is because we're in an interglacial period. By accident, 10,000 years ago, the ice melted, and that spawned modern civilization. We don't know why, by the way. We physicists and meteorologists are totally stumped as to the reason why the Ice Age ended 10,000 years ago. Perhaps small perturbations in the Earth's spin. That's the leading theory.
There was a story the other day that indicated that the Great Dust Bowl, which must have been something incredible to experience in this country, was created by a couple of degrees of ocean temperature change.
Yeah, it only takes a fraction of a degree of temperature to cause, on average, a global change. El Nino, for example, cost hundreds of billions of dollars in property damage. Again, just caused by a few fractions of a degree in temperature, and only 6 degrees or so separates us from an ice age. And so we realize how delicate the weather is that we didn't appreciate before. It's really mind-boggling and an eye-opener to see the rapid changes in the Earth's climate over the last 100,000 years. When you look at the ice cores, as I have, and you look at the rate at which the atmospheres plunged in terms of temperature, high, low, you realize that we're on a roller coaster. The Earth is not as stable as you think it is.
Well, maybe that movie will wake some people up. Here's somebody going in a totally different but interesting direction. There is this place called the Coral Castle in Florida. I bet you know about it. It's this place in Florida that this man built, having, moved stones, Professor, as the Egyptians must have. But he did it all by himself. And at one point he even took this entire coral castle he built with these tons of rocks and transferred it mystically or somehow from one place to another. He could not have moved those stones, and yet he did. Is this something that science sort of, I don't know, they don't look at it at all, or they look at it and say that's impossible, he couldn't have done that, yet we all know he did? Or how does science treat such...
Well, I'm not familiar with this.
You're not.
However, science is based on reproducible experiments, and when things are not reproducible, then of course we start to get flustered.
Yes.
With the Egyptian pyramids, for example, that you mentioned, if you read Herodotus, the Greek historian, who actually journeyed to the pyramids thousands of years ago, but again, thousands of years after it was created, he mentions that there were large wooden planks, basically the docking sites and the roads that were used by the ancient Egyptians. However, the very sites that Herodotus mentions today are nothing but sand. They've eroded thousands of years ago, but thousands of years ago they were intact and you could see them. And unfortunately, he did not describe them in detail. Otherwise, we could sort of begin to reconstruct how the Egyptians created the pyramids. It was a fantastic achievement. You can't even put a razor blade through some of those stones. But unfortunately, that record is lost. Herodotus did not write down diagrams and charts as to how the wooden structures allowed for the building of the pyramids.
We've tried to reproduce it, and we can't.
I've seen a number of science specials where you get a bunch of stonecutters together and using surveying techniques of 4,000 or so years ago. And you try to get them to reconstruct the building of the pyramids. And they do a very bad job, I must admit.
Yes. West of the Rockies, you're on the air with Dr. Kaku. Hello.
Yes, Dr. Kaku, good evening, good morning, Art Bell.
Good morning.
This is Gary from San Diego, listening to you on 600 AM Kogo.
Yes, sir.
Speaking on the topic of time travel, loved watching your interview on Chrono Trip, by the way, Dr. Kaku. Mm-hmm. Great film, Art. You should probably get a copy and check it out.
You bet.
Anyway, Dr. Kaku, I wanted to get your thoughts on cold fusion concepts that the late Eugene Malov was advocating, and if you would be willing to consider investigating the data that his supporters provided.
All right. Dr. Malov was just tragically murdered yesterday.
Is that right?
Dr. Kaku, yes.
I didn't realize. He was an acquaintance of mine. We're thinking of writing a book together.
I'm very sorry to be giving you this news. He was bludgeoned to death in Connecticut in what the police are calling an apparent robbery. But so I'm very sorry to be giving you that news.
I see. Yeah, because I had corresponded with him and talked to him on many occasions. Well, about cold fusion,
Yes.
I had long talks with Eugene, and where we differed a little bit was on, again, the question of reproducibility. He said that he had devices that could produce energy from almost nothing, it appears.
Yes.
And my attitude was that if you're going to build a Toyota car, you want to make sure that when you turn the ignition key, that the engine turns on. Not 50% of the time, not 10% of the time. You want it to be turned on all the time.
Yes.
And that's what he could not guarantee. Reproducibility, that is, other experimenters had difficulty reproducing the results of any given experimenter. And so I said that it's not quite ready for prime time yet.
Are you sure the rejection of cold fusion was across the board legitimate stuff, Professor? I mean, there are rumors out there of falsified data reports and rumors of all kinds of dark things that may have cast this, possible energy source and its discoverers into Europe because they're so fed up with what's going on. Or, I mean, how do you see it now?
Well, again, I think of it as an insurance policy. It's worth, paying some attention to this in case there is a revolutionary new quantum mechanics that comes out that makes cold fusion possible. My only disagreement with Eugene was the question of marketability, that you want a reliable technology that works every single time, otherwise you can't market it. And again, some experimenters made these very impressive claims, but they could not be duplicated by other groups. And until we have something that is 100% reproducible, then it's very hard to talk about a second industrial revolution that could take place. Now, as far as the physics of cold fusion, it was speculated that perhaps there was a quantum transition that brought the protons together. In other words, the palladium would squeeze the protons, and then you would have what is called tunneling effect. Tunneling is allowed in quantum mechanics, but the rate of tunneling is very small. It's a very small tunneling rate. Tunneling makes even fantastic things possible. For example, you could tunnel right through a brick wall.
So you thought there was something to it, didn't you?
Well, I kept an open mind. In fact, Julian Schwinger, winner of the Nobel Prize, also kept an open mind and wrote articles, in fact, saying that we physicists should not snicker so much. We should keep an open mind because there could be a new law of physics. But the rate of tunneling is very small. Again, you could tunnel through a brick wall, except you would have to wait longer than the lifetime of the universe to tunnel through a brick wall. So, but Julian Schwinger kept an open mind, and he said that we have to rely ultimately on experiment. That if experimenters could give us a reproducible cold fusion machine, we cannot laugh anymore. However, that hasn't been done yet. No one has given to us a cold fusion machine that works every time, 100%. That's the acid test for science.
What had Dr. Milov done that drove you to the point where you might have been involved in writing a book with him? I mean, he obviously was impressing you mightily in some way.
Well, he was interested in physics as well. Not only was he interested in cold fusion, but he was also interested in physics, higher dimensional physics. Mm-hmm. And that's why, we chatted together about perhaps writing a book on the latest advances in string theory, M theory, which are so fantastic. So I would talk to him about these things. And, of course, he was the editor of one of the major magazines talking about cold fusion. But, again, he was also cognizant of the fact that his scientific peers would snicker behind his back.
Sure.
There was that giggle factor. And so I think that bore down on him. But, he had this tremendous enthusiasm. You could not deny that this person was convinced. He was going to be the person that shed light to the scientific community and to the world.
Right, exactly.
Technology worked. I told him that I had my doubts, but, he was a true believer.
I'm so sorry to give you that news. First-time caller line, you're on the air with Dr. Michio Kaku. Hi.
Yes, sir. I had a question about string theory. I've studied Einstein's work for many years now, and I've been an amateur physicist for a long time. In his work, he came up with a theory of relativity and the special theory of relativity. Mm-hmm. Which you could actually apply to the very large. But when you do quantum mechanics, you have the three forces that you measure, which is the strong force, the weak force, and the electromagnetic force.
Very good, right.
Is, for the last 30 years of Einstein's life, he looked for the unified field theory or the grand theory of everything.
That's right.
I've studied superstring theory and string theory. How does that apply to the grand unification theory?
Well, string theory, we think, is the grand unified theory of everything. We want a theory, as you correctly pointed out, that summarizes not just gravity, which Einstein did, but also light and the two nuclear forces. Now, when Einstein was alive, the nuclear force was very mysterious. I mean, after all, the atomic bomb was essentially a catastrophic release of the nuclear force, but we didn't really understand the dynamics of the nuclear force at the microscopic level. Today we do. We have a very good handle on the nuclear force. We have something called the quark model, or the standard model, as it's now called, and the standard model allows us to use quarks to understand the nuclear forces that are unleashed in the sun and unleashed in a hydrogen bomb. But now we want to marry the quarks with relativity theory. That's a problem, because the quarks don't look anything like relativity theory. String theory treats both of them on the same level. A quark is nothing but a note on a string, and the same thing as a graviton. A particle of gravity is nothing but a note on a string. So the subatomic particles are nothing but notes on a string. The laws of chemistry are nothing but the melodies you can play on strings. The universe is a symphony of strings. And the mind of God that Einstein eloquently wrote about is music. The mind of God is music resonating through 10, maybe 11-dimensional hyperspace. And then, of course, that begs the question, is there a composer if the mind of God is this cosmic music that we've been talking about? But if this theory is correct, then all the forces are nothing but musical notes. And we have many particles.
I believe that when we break it down to its smallest level, that everything acts as a wave and not as a string.
Oh, yeah, but you see, the waves and strings are basically the same thing. Even particles have wave-like nature, and the strings have wave-like nature. So ultimately, you're right. Everything can be reduced down to a wave. But what is waving? What is waving is a string, we think. Now, we can argue as to what the string itself is. My personal point of view is the string itself is the condensation of space. Einstein believed that there were kinks that you could make in the fabric of space and time. If you have a bed sheet, many times kinks form, and Einstein thought that maybe these kinks correspond to particles. If this is true, these kinks could actually be strings, in which case strings are nothing but the condensation of space.
The condensation of space?
Yeah, that's Einstein's direction. That's where he was going in the last decade of his life. He was leaning toward the idea that kinks in space are represented as particles. And the particles, of course, are electrons and atoms.
Is there on Earth now that we recognize in Einstein, is there somebody at Einstein's level now?
Well, one of the main engines behind string theory is Ed Witten. He is hands down the leading string theorist. And he believes that, this theory is, 100 years more advanced than we were supposed to see. We were not really supposed to see this theory in this century. It was really a theory for the next century. But no one on Earth is smart enough to solve the theory. The basic equations of string theory, many of them I wrote myself, but the basic equations of string theory cannot be solved completely. And Witten, of course, has given us tremendous insight into these solutions that has staggered the world of science. But no one has gotten our particular universe yet out of string theory. And no one knows where string theory comes from yet. It's not a solvable theory because it's too complicated. The human mind has a very hard time grasping the mathematics of string theory. Even the mathematicians were shocked when this theory was proposed.
Yes.
It's bowled over the world of mathematics.
Well, Professor, our time is up. I hope your book rages out there, and I trust it will, and I really hope that network, and I know that they listen, these large networks. One of them comes to you and offers you an opportunity to do a prime time something, because our nation needs it, and you're the right one to do it. And I thank you for being here with us tonight.
My pleasure. Anytime, Art.
You never know. Maybe I'll see you in New York. Take care, my friend.
Okay, I'm right here.
There you have it, Dr. Michio Kaku. And there's just nothing quite like it. is there to have an opportunity to chat with that man? Well, it's been a pleasure, and one last time I will mention to you that next week, Ramona and myself will be in New York attending the premiere of this wild movie called The Day After Tomorrow. So, y'all take care, and I'll see you in 2 weeks. From the high desert, Crystal Gale is her name, just the right words to get us out of here.
Good night in the desert.
Good night.
Shooting stars across the sky.